Good evening, students. Followed by electrical actuator, we'll move to the next one, which is a pneumatic control valve. Okay, so here let us explore what is a pneumatic control valve. It is a main final control element which is used the pneumatic, that is air as a input, which is used for opening and closure of the control valves. Okay, so when you take a pneumatic control valve, this is the schematic diagram representing a pneumatic control valve. Okay, so it is exhibiting the second order dynamics. Okay, so you can see that we have a diaphragm in the top, and followed by there will be a stem which is attached, okay, stem, and over the stem there is a spring is attached, and below the stem there will be a plug and seat is at the end of the stem. Okay, so here the position of the stem is determined by the balance of the force. Okay, so this is a construction of the pneumatic control valve. There will be a diaphragm at the top, followed by a stem which is enclosed with a spring, and bottom of the stem will be a plug, and there will be a seat is there which allows the flow through the pipeline. Okay, so here let us see the mathematical model of the pneumatic control valve. What are the forces acting on the pneumatic control valve? So as I already said, it is going to be treated as a second order system. So there will be a force exerted by the compressed air at the top of the diaphragm. Let us represent that as P into A, and there is a spring attached with that, and that is represented as a force exerted by the spring attached to the stem, which is represented as K into X, and followed by C into dx by dt is a frictional force exerted upward, and resulting from the close contact of the stem with wall packing, where C is a friction coefficient between the stem and packing. Okay, so coming to the mathematical model of the pneumatic control valve, P into A minus K into X minus C into dx by dt is equal to m by gc into d square x by dt square. The same can be represented as a second order standard form of second order equation, like m by k into gc d square x by dt square plus c by k into dx by dt plus x is equal to p into a by k. Okay, so let us represent the same as a second order equation as tau square s square plus 2 zeta tau s plus 1 is equal to kp into p. Okay, so from this you can represent the transfer function for the second order equation. Okay, so this pneumatic control valve can be treated as a second order system. Okay, so thank you, students.